So why is deep learning taking off now? I think that the biggest trend, the number one reason that deep learning is taking off just in the last several years is scale. And so I like to make an analogy to building space rockets. I think building AI is like building a space rocket. So what is a space rocket? To build a rocket, you need a huge engine, right? 巨大的引擎, and a huge amount of rocket fuel. And both need to be huge. If you have a rocket with a huge engine and a tiny amount of fuel, you won't go very far. If you have a tiny little engine and a huge amount of fuel, you might not even lift off. It's only with a huge engine and a huge amount of fuel that you can build a great rocket. So the analogy is that the rocket engine is the huge neural networks that we're now finally able to build, thanks to really Moore's law and scaling much faster than Moore's law with advances in GPUs. And the rocket fuel is the huge amount of data that leading internet companies and many of you probably now have access to. And so algorithmic innovation has been important too, but one of the most reliable formulas for improving machine learning progress is build a big network, give it lots of data, right? So over the past several years, this has been some trends I saw, right? Just as the community, as we drove scale of machine learning. About 10 years ago, most of us were training neural networks on normal CPUs, and back then we were training networks with about 1 million connections, so progress was slow. About, I guess, 2008, we wrote our first paper on training a neural network on CUDA. And so that allowed us, this was at Stanford, to scale up neural networks about 1 order of magnitude, right? And then I think 2011, when I was leading the Google Brain team, we used CPU computing to scale this up even more with many CPUs. But shortly after, we realized that cloud computing, many CPUs, is not a good way to scale up deep learning. And so at Stanford, and then later at Baidu, we realized that using HPC, right, 高性能算法, and more recently, the supercomputers is a much more promising way to scale up these deep learning algorithms. And so I think that the bleeding edge, really, the most advanced deep learning systems today are shifting to HPC, to high-performance computing. To give an example, to train our speech recognition system today, it takes about 10 exaflops, actually maybe 20 exaflops. So this 10 to the 19 flops, it costs us about $100 of electricity just to train one model. When one of our researchers trains one model, they spend about $100 on electricity. And we train on about 4 terabytes of data, now up to about 50,000 hours of data. And so I think at Baidu was the first company, first large company to build a GPU cluster for deep learning. 我说的意思是全球第一，不只是中国第一, right? We're also the first company to announce, first large company to announce putting GPUs into production, not just training, but serving. And I think our early investments, our early bet on GPUs has enabled us to sustain a lead that has helped our researchers and our AI capabilities. So I want to go into just one case study, go deeper into one example of how deep learning is transforming many AI applications at Baidu.